Chapter 15, Combinatorics. Pronounced combinatorics, not combinatrix. Section 15-2, the multiplication, addition, and complement principles. If an action can be performed in n sub 1 ways, and for each of these ways another action can be performed in n sub 2 ways, then the two actions can be performed together in n sub 1 times n sub 2 ways, as so. Example 1. If you have 4 different letters, A, B, C, and D, how many ways can you arrange them? You may repeat the same character. For example, A is permitted.
You have 4 slots. The first slot has 4 possibilities: A, B, C, and D. If repetition were not allowed, the second slot could only have 4 minus 1 or 3 possibilities. However, since repetition is permitted, the second slot also has 4 possibilities. Henceforth, the third and fourth slots have 4 choices also, since they are under the same constraints. When this is illustrated in a tree diagram, we see there are 256 possibilities. However, we can achieve the same result by utilizing the multiplication principle. 4 times 4 times 4 times 4, or 4 to the power of 4, equals 256. Note: factorials, or the exclamation mark. This concept is extremely vital in understanding permutation and combination, explained in section 15-3. Going back to the previous example, if repetition were not allowed, the first slot would have 4 possibilities: A, B, C, and D. The second slot would have 4 minus 1 possibilities, because we cannot repeat the letters used in previous slots. The third slot and the fourth slot follow the same conditions, and therefore will have 2 choices, and then 1, respectively. 4 times 3 times 2 times 1 equals 4 factorial. The exclamation mark can be found in the math function of your TI-83, 83 plus, 84 plus, 84 Silver Edition, TI-89, and the newly released TI Inspire as of 2008. Section 15-3, Permutation and Combinations. Permutations. This concept is utilized when you choose R number of things out of a total of n things. In permutations, order is important, as shown in the following example. For example, if you were to choose 3 letters out from the choices of A, B, C, D, and E, how many ways can you assort these letters under this condition if orders of the letters matter? For example, A, B, C, and B, A, C are considered different. In this, n equals 5 and r equals 3. Therefore, the expression for this will be 5 permutating 3. There will be 60. You may assort the letters under these conditions. Combinations. This concept is used when you choose R number of things out of a total of n things. In combinations, however, order is not important, and the formula is as follows. Going back to the previous problem, if you were to choose 3 letters out of the choices of A, B, C, D, and E, how can you assort these letters under these conditions if the orders of the letters are negligible? For example, A, B, C, and B, A, C are considered the same. In this case, we use the combination formula. N equals 5 and R equals 3. Therefore, the expression for this will be, there are n ways to assort the letters under these conditions. 15-5. The binomial theorem and Pascal's triangle. When you expand the terms a plus b to the n for positive integers of n, we result with the following diagram, which is known as Pascal's triangle. Notice that each number is the sum of the two numbers above. Using this, it is easy to figure out the sixth row of the triangle. Simply add the two numbers above. At this point, it might seem like you must row to be able to find the sixth row. However, this is not the case.
Instead, use the binomial theorem.